Well, this is a worked example for the integration section for integration by parts. This particular one we're doing relatively straightforward integration. That's x times the natural log of x. So if we recall the lesson on this, what we need to do is we need to use this particular formula here. Now, this is a kind of simplified thing, really. We haven't got the dx's in here, but this is in a form that can more easily remember. We'll just assume that the dx's are in there. So what we're saying is the integral of u times the derivative of v is equal to uv minus the integral of u, the derivative of u times v. Okay, now this particular formula has been derived from the equation for differentiate the product rule for differentiation, and so it's kind of fairly easily derived, and we can use this. Now you might say, you know, what use is this? We're starting with one integral and we've got another integral. But as we can see from the process illustrated by this example, then it hopefully will lead to a simplification. All right, so we've got u's and v's in this particular equation here. So what we have to do is we have to decide which of these factors here, x or natural log of x, is going to be assigned to u, and which is going to be assigned to, well, not v, but v prime. Okay. And now in order to decide our u, we have to, we refer to this islate thing here. We're not kind of usually too bothered about the inverse trig. It's these here. And so what we're saying is that the type of function that's higher in this this list gets to be u. So our log factor here is basically going to be our u, and therefore x is going to be the derivative of v. So if we just write that out, u equals natural log of x, v prime, the derivative of v, is equal to x. Okay, so now that's therefore implies if we take the derivative of u, well, we get 1 over x, and if we integrate v prime to get v, then that's half x squared. So now we've got the 4 components here that we can plug into this equation. Okay, so we'll do that. So first of all, we've got u v prime. So that's our u, that's our v prime. Okay, that's what we started off with. Equals the uv, so it's the natural log of x, that's u, and this is the v that we've obtained from our process here, going from this v prime equals x to this v here. So that's what that is. Minus, well, we've got u prime. So u prime is the derivative of natural log of x over v, 1 over x, times v again there. So we've got to integrate this with respect to x. So that's just rewriting this as a slightly different arrangement. Equals right. Okay, well, the thing about this, of course, is we've got some cancellation here, and this is the point of the method, really, and this is why if we choose our u and our v sort of appropriately, then this is the sort of thing that we can expect to happen. Yeah, so we've got we take the half outside, we've just got the integral of x. The integral of x is obviously half x squared, so those two together with the half that's outside, the integral sign, and we get this expression, and so we're done. Perhaps you know, worth just factorizing out a quarter x squared to give us this as just an alternative expression. This probably serve equally well, but there we go. So our integration by parts formula has worked very nicely. Okay, so hopefully that has been useful.